Hey there, and welcome back. We're going to be studying the Pythagorean theorem today, one of the most useful theorems that you'll ever learn, and it has to do with what we've been studying the past few weeks. It involves a theorem or a rule involving exponents. So the learning target here is to know and apply this theorem, the Pythagorean theorem, to find unknown lengths of something. The success criteria for this is going to be to plug the appropriate side lengths into their corresponding variables in that theorem. We're going to use the inverse operations to solve for those unknowns, and we're also going to use the Pythagorean theorem to determine if a triangle is right. Okay, so the Pythagorean theorem, there was this ancient Greek philosopher named Pythagoras, and he was doing a lot of experimentation with triangles. And what he noticed was there was a common pattern to all of the triangles that had a right angle in them. So let's go over right triangles. It says in a right triangle, the two shortest sides are legs. So I have that written here, that there's a leg, and the two legs are actually connected by that right angle symbol. The right angle symbol holds the legs together. The longest side, which is the opposite of the right angle, is called the hypotenuse. Hypotenuse. Not hippopotamus, not hyptenuse, hypotenuse. Okay, the hypotenuse is the longest side, and the right angle will point to the hypotenuse. Now, what Pythagoras figured out, what he kept experimenting with different side lengths, and he tried to notice a pattern. What he figured out was if you square, or you times by itself, the two legs, okay, so notice how they square the legs, and then you also add them together, that equals the hypotenuse's value squared. So what he did was he said, okay, let's call the legs A and B for variables, and we'll call the hypotenuse C. Now, you can call either one of the legs A or B, okay? I could have also named this one B and this one A, okay? It doesn't matter which leg you call A and which leg you call B, but it is extremely important that you make sure that the variable C is the hypotenuse or the longest side, or the side that the right angle points to. Okay, so the C right here in the theorem, this is Pythagoras' theorem. A squared plus B squared equals C squared. Okay, C squared, C has to be the longest side, or the side across from the right angle. That was the pattern that he noticed. If we plug in variables, if we plug in a value for a leg into the C variable, then it's not going to be the correct pattern, and you're not going to be able to solve for those unknowns. So thank you to Pythagoras for coming up with this theorem, because there are lots and lots of right angles in our known world, which helps a lot of regular people do their job when we have to know the length of an unknown side. So we are going to use this theorem, a squared plus b squared equals c squared. Sometimes you may be given A and B and you need to solve for C, or sometimes you may be given B and C and you need to solve for A. Okay, you can solve for any of the unknown side lengths in the theorem. So we're going to practice doing this in the first example. Now, in all of these 4 different examples, we're going to be missing one of the legs of the triangle. Okay, so if you notice, okay, again, let's look at this first one. The right angle symbol connects the legs together. So let's call the one that we're missing, let's call that A. And then this one we'll be calling B, and then C should always be the hypotenuse, or the value across from the right angle. So in order to properly memorize Pythagorean theorem, make sure you write it down on all of your examples. So our theorem was A squared plus B squared equals C squared. Now plug in the values that we know. We know the values for B and C. So let's leave A squared the way it is. We'll plug in 12 for B. So 12 squared equals C squared, which is 13. So 13 squared. Okay, so now I'm just going to actually simplify and try to solve. I have A squared plus 12 squared is 144. and 13 squared is 169. So now, as we've practiced, this was a little while ago, but we practiced solving equations like this when we had squares and even when we had addition or subtraction involved. So remember your order of operations. Please excuse my dear Aunt Sally. Or parentheses, exponents, multiplication, division, addition, subtraction. Whenever we solve, we go backwards because we're undoing that order of operations. So the first you should look for is any addition or subtraction. Well, I do see that 144 is being added. So we have a squared plus 144. I'm going to scoot over the equals 169 because I have to insert on both sides of this equation that I want to minus 144. Because that will make the positive 144 subtract with 144, making 0. That's what we want. And then we'll just have a squared left over. Now we need to do 169 minus 144, which is 25. And now it looks like one of the equations we solved really often when we were solving the x squared equations. We just need to undo that square by square rooting both sides of the equation. The square root and the square will cancel, leaving just a. And then during our lessons when we first learned that, we said we needed to write the plus and minus version. But since we're dealing with side lengths of a triangle, this is just going to be the positive version. So the square root of 25 is 5. That means the side length for A is going to be, and it looks like they have them in meters, is going to be 5 meters. That's our answer for that one. Okay, so basically we're going to repeat this process 3 more times in these examples. And sometimes you may get decimals and you may have to round. And eventually there can be times where you could even memorize certain Pythagorean triples. We're going to talk about that a little more when you get to your U-try. So let's do the Pythagorean theorem again here on the second example. Again, the legs are connected by the right angle. So I'm going to call this unknown A. I'm going to call this other leg is going to be B. And this other side, which is the hypotenuse across from the right angle, is going to be C. It's very important that 15 meters is the C. The 9 meters has to be one of the legs. A and B represent one of the legs. So again, I'm going to write the Pythagorean theorem. A squared plus B squared equals C squared. The more times I write it, the easier it is for me to memorize. And now I'm going to plug in the values that I know. So I'm keeping a squared unknown plus b squared, which is 9 squared, equals 15 squared. So now I'm just going to actually square the 9 and square the 15. I get a squared plus 81 is equal to 225. And it's the same steps as before, so I'm really just going to subtract that 81 from both sides. So a squared plus 81, sorry about that, minus 81 is equal to 225 minus 81. The positive 81 and the negative 81 will become 0, and we're left with a squared is equal to 144. Last step, we just need to square root both sides. And we get that side length A is equal to 12 meters. Okay, so I'm going to fill that in. A is equal to 12 meters. Okay, let's do this a couple more times. And now once you've seen it 4 times, I do expect you to be able to do this on your own in your U-try. Okay, so again, I'm going to have my right angle symbol connecting my legs. So let's call this one A. We'll call the other leg B. And then the one across from the right angle, or the longest side, is going to be C. So I have now a squared plus b squared equals c squared. That's the 3rd time I've written that theorem. Hopefully it's starting to stick into our brains. Okay, so I have a squared plus 10.5 squared is equal to 17.5. Don't let those decimals throw you off, and don't round until the very end. And I would even suggest only rounding after you square root. Okay, your very last step should be to round. If you round in between steps, it's going to skew your answer. So let's pull out our calculators. I've got a squared plus, see, 10.5. I need to square that, and I'm getting 110.25, or 110 and 25 hundredths. So 110 and 25 hundredths. Don't round that. Keep it the way it is. Now we just need to square 17.5. I'm going to clear that out. 17.5, square it. I'm seeing 306 and 25 hundredths. So equals 306 and 25 hundredths. So now we're just going to solve just like we did before. We have a squared plus 110 and 25 hundredths minus 110 and 25 hundredths is equal to 306 and 25 hundredths minus 110 and 25 hundredths. So I'm going to go back to my calculator because these become 0, but I'm going to quickly just type in what 306 and 25 hundredths minus 110 and 25 hundredths is. There we go. Got to clear that out first. There we go. 306 and 25 hundredths minus 110 and 25 hundredths. Okay, so I'm getting 196. So a squared equals 196. Last step, square root both sides. And we're left with a is equal to 14. So my unknown side length in this third example is 14 meters. Got one more example for you. I'm sure you guys are probably like, all right, we get it already, but I do want to show you one last one, and then you can go ahead and try it on your own. Again, I'm going to rewrite my Pythagorean theorem. A squared plus b squared is equal to c squared. I have my legs being connected by the right angle, so I'm going to call my unknown A. I'm going to call my other leg B, and always the longest side, or the side across from the right angle, C. So I have a squared plus 15 squared is equal to 25 squared. A squared plus 15 squared, that's 225, is equal to, now I don't know what 25 squared is off the top of my head, so I'm going to go to my calculator. Clear that out. 25, square it. Looks like 625. Okay, so equals 625. And now I do the same thing that I did in the last couple. I want to get rid of any addition or subtraction. I have that plus 225, so I have to minus 225 from each side of the equation. The positive 225 and the negative 225 become 0, and we're left with a squared is equal to 625 minus 225, that's 400. Last step, square root both sides. We're left with just a, and the square root of 400 is 20. So my unknown side length here is 20 meters. So I've got 4 different examples here. The first one was 5 meters, the second one was 12 meters, the third one was 14 meters, and then the fourth one was 20 meters. Okay, I know it looks like a lot of work, but the more and more you practice this, it becomes really, really easy, and you don't even forget the theorem after a while. It's like a part of you. Just keep doing what I did by writing down the formula over and over and over again, and then it becomes the easiest formula to apply, and it really is one of the most applicable formulas in the real world. So let's have you guys give this a try on your first U try. Find the unknown leg length. right, so I have one more you try I want you to do, and this is just to kind of extend the first idea we were talking about. Pythagorean triple is a set of three non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. Now, in that order, a, b, c, 3, 4, 5, 6, 8, 10, and 9, 12, 15 are examples of these Pythagorean triples. Find a relationship amongst these Pythagorean triples and make a conjecture. Okay, when I say conjecture, I mean hypothesis. Okay, there are a lot more Pythagorean triples than just these three. There's lots and lots of them. And Pythagorean triples are basically just whole numbers that satisfy the Pythagorean theorem. So if I were to plug in 3 for A, okay, so let's write the Pythagorean theorem out. Let's plug 3 in for A, 3 squared, 4 in for B, 4 squared, and then 5 in for C, 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is 25. So I get something that is true. Okay, that's what a Pythagorean triple is three whole numbers that satisfy the Pythagorean theorem. So there's other Pythagorean triples. There's one other one that's 5, 12, 13. Okay, and there's actually a lot more that you could memorize so that if you see on a triangle the side length of 5 and then a hypotenuse of 13, you would already know what the third side length is. It has to be 12 because 12 is the only number that would satisfy the Pythagorean theorem. So what I usually do is I just memorize that 3, 4, 5. That's actually my favorite Pythagorean triple. So what I want you to do is to look at the other Pythagorean triples that they list. Do you see any pattern between 3, 4, 5 and 6, 8, 10 and 9, 12, 15? Is there anything that you spot, and what is a hypothesis you can make about Pythagorean triples, and particularly this one? Alright, so in these examples, I'm really just going to be using the Pythagorean theorem again, but if you notice in all three of these triangles, the hypotenuse is missing. The side across from the right angle is missing. So we're still going to use, and just so you guys are aware, these are just options. Okay, those are possible answers. So if you're having any trouble doing the calculations, you can look up to the possibilities and see if they fit. Now, kind of like on the U-try, you can also recognize Pythagorean triples. In fact, in this first triangle, I recognize a Pythagorean triple, the one they were talking about, the U-try 1.5. The first Pythagorean triple that we talked about was a 3, 4, 5. Well, I see side length 3, side length 4, so I can assume that this side length is going to be 5. Okay, that's how Pythagorean triples work. If you memorize a Pythagorean triple, then you don't need to show the work to get to the Pythagorean to get to the last Pythagorean side length. Now, I will show the work just to make sure you guys are aware of what it should look like, but I think when you're solving for a hypotenuse, the work is actually a lot easier. So let's write out the Pythagorean theorem just like we have been, a squared plus b squared equals c squared. And remember that the hypotenuse is where the right angle points to the longest side. So the hypotenuse is right here. That's going to be your C value. Okay, this is going to be A, and this is going to be B. Or you can switch A and B. The C is the only one that actually needs to be the longest side. So I have 3 squared plus 4 squared equals C squared. That's 9 plus 16 equals C squared. 9 plus 16 is 25 equals c squared, and then you just need to square root both sides. Now I find that process to be slightly easier than having to solve for one of the legs. But again, like I said, if you recognize a Pythagorean triple, especially a 3, 4, 5, you don't necessarily need to show the work in how you got the remaining side length. Now this one, it's not going to be impossible to memorize all the Pythagorean triples, but that's a lot of memorizing. I don't recognize if this triangle is a Pythagorean triple, so I am going to go ahead and just use my Pythagorean theorem like normal. I'm going to call my two leg lengths A and B. And again, it doesn't matter which one you label A and which one you label B, but then this one's got to be C. So I've got A squared plus B squared equals C squared. That's going to be 7 squared plus 24 squared equals C squared. 7 squared is 49. 24, I don't know off the top of my head, so I'm going to have to use my calculator. There we go, 24 squared. That gives me 576. So 49 plus 576 is equal to C squared. You could also use your calculator again to do 49 plus 576. Now I've already got 576 still in my calculator, so I'm just going to type in plus 49. That gives me 625. So I've got 625 is equal to C squared. And then I just need to square root both sides. So that gives me that C is equal to, and I actually remember this from the previous example, if we were to square root 625, we're going to get 25. So the third side length, or the hypotenuse here, C is going to be 25 centimeters. Okay, I got one more example for you guys, and I'm sure now that I've been using the Pythagorean theorem over and over and over again, it's getting a lot easier for you. I'm just going to show one more, and this one I do recognize as a Pythagorean triple, but I am going to show the work. Again, write out your Pythagorean theorem, so we're committing it to memory. We're going to call the two legs A and B. This will be A, this will be B, and then our unknown will be C, because it's across from the right angle. So I've got 12 squared plus 5 squared is equal to C squared. 12 squared is 144. 5 squared is 25. And now 144 plus 25, that's 169. And we need to square root both sides. The square root of 169 is 13. So the side length over here, C, is going to be 13 centimeters. Okay, that's 3 examples. 3 times I showed you how to solve for the hypotenuse this time using the Pythagorean theorem. So let's have you give this a try. Give this a try in your U-Try. They don't give you a picture, but feel free to draw a picture and label what they tell you you have. All right, so in this third example, this actually is one of the real-life examples that you can find to use the Pythagorean theorem on. It says the length of a diagonal of a television screen is 42 inches. The length of the bottom of the screen is 36 to the nearest tenth. What's the height of the television screen? Now, in fact, this is a real-life thing. A lot of televisions are, they're measured by their diagonals. So if you're wanting to know if a TV screen is going to be able to fit in a certain area in your home, you may need to apply the Pythagorean theorem. Well, again, the hypotenuse is across from the right angle symbol. So this 42 inches has to be the C value. Whereas the 36 can either be A or B. Let's just call the unknown side length the height A, and we'll call that 36 inches B. Again, it doesn't matter if you were to call the 36 inch A and then the unknown B. I usually just make my unknown the A. Okay, so again, I'm going to write down my Pythagorean theorem, which is A squared plus B squared equals C squared. I'm going to replace C and B with the known values. So I have A squared plus 36 squared is equal to 42 squared. Now, I don't know 32 and 42 squared off the top of my head, so I have to go to my calculator. So let's see, 32 squared is 1024. So I've got a squared plus 1024 is equal to 42 squared, which is equal to 1764. So now I just need to use my solving skills here again. Actually, I'm going to write over here. I've got a squared plus 1024 minus 1024 to get rid of it on the left side is equal to 1764 minus 1024. That makes it 0 on the left side. That's exactly what we want. We have left a squared is equal to, I'm going to go to my calculator again. I already have 1764 in there, so I'm just going to subtract 1024, giving me 740. So a squared is equal to 740. And then I just need to square root both sides. The square root and the square will cancel. And we're left with a is equal to, and then I just need to type that in my calculator, and that's where the rounding instructions come into place. It says round to the nearest tenth. So I'm going to do the square root of 740. That's equal to 27 to the nearest tenth, looks like 27.2. So a here is 27.2 inches. That's how tall this television is, 27.2 inches. Okay, so what I would like you guys to do now that we've had a real life situation of using the Pythagorean theorem, I want you to do this exact same thing on this real life example on your U-Try. It says a baseball diamond is a square with 90-foot side lengths to the nearest tenth. What is the distance from home plate to second base? So even though you have a square here, I just want you to focus your eyes on the triangle. Okay, the triangle, which in this diamond, the right angle would be right here. That would make this 90-foot A, one of the legs, and this 90-foot B. And since across from the right angle is the hypotenuse, the distance you're looking for is your C. So use the triangle that I've highlighted here to find the hypotenuse C using the diamond side lengths. Go ahead and give this a try. Alright, so my last example, what I want to do with the Pythagorean theorem is actually show if a triangle is right. Now, if a question asks you, is the triangle a right triangle and justify, they are always going to make it look like they are right triangles, but they're not going to actually draw the right triangle symbol in the triangle. So what your job is to actually apply the Pythagorean theorem, and these are your two options, yes or no. Is it a right triangle or is it not? What you need to do to show in your work is plug those three numbers into the Pythagorean theorem, and if it's a true statement, then it is a right triangle. If it's not a true statement, then it's not a right triangle. Keep in mind, the longest side has to be plugged in for C. That's the hypotenuse. So call A and B, whichever the other two you want, but the longest side has to be C. So in this first triangle, the longest side here is 10. So that has to be C. The other ones can be A and B. Doesn't matter which one's A, doesn't matter which one's B. So I'm going to write my Pythagorean theorem out again. A squared plus B squared is equal to C squared. I've labeled A as being 8. So 8 squared. I've labeled B as being 6. So 6 squared equals then 10 squared. So I'm just going to simplify both sides of this equation and see if it becomes true. 8 squared is 64. 6 squared is 36. And 10 squared is 100. When I add 64 plus 36, I get 100. So since 100 equals 100, this being a true statement, 100 does equal 100, that means that this triangle above is a right triangle. Okay, so yes, this triangle is a right triangle. Now let's try it again on the next couple triangles and see if those are also right by using the Pythagorean theorem. So again, longest side should always be C, so the 6 is going to be C. We'll call 4A, we'll call 5B. A squared plus B squared equals C squared. That's 4 squared plus 5 squared equals 6 squared. That's 16 plus 25. Does that equal 36? 6 squared, which is 36. 16 plus 25 is actually 41. So since 41 does not equal 36, then that means that this is not a right triangle. Even though they drew it to look like a right triangle, those side lengths that they gave us do not form a right angle. Okay, so even if you're given decimals, do the same thing. Don't let decimals scare you off. It's the same exact process. A squared plus B squared equals C squared, where the longest side should be C. So 6.5 here should be C. We'll call 2.5A, and we'll call 6B. So we've got 2.5 squared plus 6 squared equals 6.5 squared. Now, since that's a decimal, it's not whole numbers, I may need to go to my calculator. So I've got 2.5 squared. I don't want to round that either, 6.25. So I've got 6.25 plus 6 squared, which is 36. Does that equal 6.5 squared? Okay, well, 6.5 squared is equal to 42.25. When I do 6.25 plus 36, I do in fact get 42.25. Okay, you can check that in your calculator. Type 6.25 plus 36. You're gonna get 42.25. So this triangle is, yes, a right triangle. Last one. I've got side lengths 4, 7, and 8. Again, the longest side should be the hypotenuse. So 8 is going to be C. And then the other two can be A and B. Doesn't matter which one's A or which one's B. Again, I feel like I've definitely committed the Pythagorean theorem to memory, but I'm going to write it out again. A being 7, B being 4, C being 8. 7 squared is 49. 4 squared is 16. Whoops, sorry about that. And 8 squared is 64. 49 plus 16 is actually 65. So even though they're close, 65 and 64, they're still not equal. So this last triangle is still not a right triangle. Okay, so that's what they're trying to do here. They're trying to give you triangles that look to be right, and you are verifying if they are in fact right by plugging in their side lengths into the Pythagorean theorem. So let's have you give this a try in your fourth and final U-try. Which lengths represent the side lengths of a right triangle? I want to see you plug in each of these possibilities into the Pythagorean theorem and seeing if they hold true. All right, I've got one last close and check question for you to make sure you know what you're doing. Again, don't worry that they're decimals. Just go ahead and plug into the Pythagorean theorem. Please make sure you ask any questions if you don't know how to set this up. And if you need to, you can go back and rewatch any of the portions to make sure you know how to do this on your own. Give it a shot. Alrighty, that just about sums up our lesson for today. We applied the Pythagorean theorem to find unknown side lengths. Our success criteria, first thing we did was we plugged into the appropriate side lengths into their corresponding variables into the theorem. We used inverse operations to solve for those unknowns, and we used the Pythagorean theorem to determine if the triangle was right. Okay, we did the first two success criteria in both examples. We did that through example 1 through example 3. And then the fourth one, or the third success criteria, was in the fourth example. Please make sure you go back, rewatch any sections you may need to if you didn't quite understand. Stop and pause the video, get any questions answered. But if you feel like you got it, go on to your Google form and have a great day.